Okay, here I have a function right here, and I'm gonna go over a through e. I'm not gonna do f. Okay, so the first thing is we're gonna find an increase and decrease. So in order to do that, first thing you do is find the derivative. Okay, then you set it equal to 0, and then you find when x equals 0. Okay, so that's your critical point. Okay, so this is my critical point, and then you use the critical point 0, positive, negative 1 right here. And then you set it up a timeline or whatever, a number line, and you see if it increased or decreased. So here, remember this negative infinity to negative 1. Okay, I chose a number between negative infinity to negative 1. I chose negative 10. Negative 10, you're gonna put it into your into this function right here. Okay, you see f prime, and put it into this function. Replace the x, these two x into negative 10, and you solve it, and the answer will become negative. Okay, so it's negative. Now you choose a number between negative 1 and 0, so I chose negative 0.5. Now you put negative 0.5 into x, you substitute it, and it will become a positive answer. You can do it again and again. See, let's say you want to do 100, okay, from 1 to infinity, so I chose 100. Okay, substitute x as 100, and then you solve it. It's going to become a negative answer. So here you can see that it's negative. It's increase, decrease, increase, increase, and decrease. So that's what I wrote down here. Okay. Now that we're done with, we are done with A. Now B. Find local max and min using the first derivative. Okay, that's what we're gonna do. Find the local max and min. We're gonna use the same chart. You can see that it goes down and go up. That's gonna be our minimum, local minimum. Okay. And now here it goes up and it goes down. It's like a mountain in this case. You see what I'm saying? It's a mountain. So our local max is going to be at 1, okay? And our local min is going to be at negative 1. In order to find the y value, you plug in negative 1 into the original function, okay? Right here, you plug it in, and then the answer will be negative 2. To find the same thing here, you plug in 1 into the original. Do not plug into here. You're gonna get it wrong. Alright, moving on. Now we're gonna go to C. Find local max and min using the second derivative. Okay, so we do the second derivative. Okay, and when I was doing it, I made a big mistake because I was finding the critical point. I set it equal to 0, and I found the critical point right here. Do not do that. Use the critical point from f prime of x, which is right here. Use this one right here. Okay, and do not find a critical point from here. So I'm gonna use this right here, and so I have 0, positive, and negative 1. Okay, and I'm gonna plug it into f double prime of x. Okay, so when I plug it in negative 1, I'm going to get the answer 30, negative 30, and 0. So see, 30, negative 30, 30, negative 30, and 0. Okay, in this case, it's going to be weird, okay? When originally I thought 30 was going to be my max, but no, okay? If it's more than 0, it's actually going to be your local min, and if it's less than 0, it's going to be your local max. Remember that. It's like opposite, okay? So this is going to be a local min, okay, 30, because it's more than 0, not local max. So this is going to be 30 is more than 0, local min, okay? So we're going to use the negative 1 right here as our x value. And to find y, we plug it into the, once again, the original equation, which is right here, okay? And that's going to be negative 2. And negative 30 is less than 0, so it's going to be our local max. I know it's confusing, no? And then you're going to get 1, 2. And if you look right here, it's the same answer as that, see? So there's two ways of doing it. You can do the first derivative, or you can do the second derivative, okay? That's how to find your local min or max, okay? Now let's move on. What's our next step? Now we're going to find the global max and min. In this case, I couldn't find it because I was not given a domain. But let's do a problem where they provide a domain, okay? So here we have, ignore this sentence right here. Here we have f of x equals x squared minus 4x plus 5 in the domain of 0 and 3, okay? 0, 3. So what I did, in order to find the absolute maximum. This is to find absolute maximum or global maximum. This is the same thing. You find a derivative, okay, which equals this. Then you set it's equal to 0, and you find your critical point, x equals 2, okay? And x equals 2, so now you use 0. X equals 2, the 2 is within the 3, so you can use it, okay? So 0, 3, and 2. Let's say, if, for example, if it's x equals 2 and x equals 5, okay? We cannot use 5 because it's not in the domain, okay? Just letting you know. In this case, we can. Okay, so anyways, 0, 3, and 2, you plug into the original function. And here I got 5, 2, and 1. So this one's our absolute minimum at 1 when x equals 2, absolute max at 5 when x equals 0. Okay. This is a total separate problem. This is not, see, this is not part of this, so don't get confused. Okay. So once again, I want to repeat real fast that find a derivative and then you plug it into the original function here. Okay. So yeah, we already did this. Once again, we cannot find a global maximum of this because we're not given a domain. So now we're gonna find a concavity and inflection point of this right here. Okay, so concavity and inflection point. Here it is. So we find the second derivative. Okay, right here. We set it equal to 0. Okay, and now you do the number line, which I did. So here's a critical point, 0 and positive negative 1. Okay. So I put it down. Okay. And then now you choose a number. So let's say you choose negative 100. Okay. And you plug it into here. Plug into this. It's gonna be a positive number. Okay. Once again, negative, positive, negative. So that's concave up, concave down, up, down. Okay. So that's what I wrote here. And then inflection point is when it changes, see, up. I mean, you see it changes from up to down, and then down to up. Those are your IP. So the IP is gonna be here. Okay, and then to find the y value, you plug in this right here to the original function. See, original, and then you get that. Okay.